Good evening, class. It's Mrs. Albright, and tonight we're working on Module 5, Lesson 26, and our objective is to use reasoning and benchmark fractions to compare and order fractions greater than one whole. So this is really more of a logic and reasoning exercise as opposed to math calculations. Remember, we did a lesson before with fractions less than one whole where we used 1/2 to be able to compare fractions. And we looked at where fractions were on a number line in terms of how close to one or how far away from one they were in order to put fractions in order. So for this first scenario, we have a story problem. Barbara needed 13/4 cups of flour. Her friend Jeanette needed 9/2 cups, and her friend Robert needed 3 6/8 cups. Let's compare the amounts using a number line. So the first thing I want to do is to identify the fractions that I'm dealing with in this problem. So I'm going to go ahead and circle. I have Barbara with 13/4 cups, Jeanette with 9/2 cups, and Robert with 3 6/8. So I'm going to go ahead and rewrite those fractions. I've got 13/4, 9/2, and 3 6/8. So the first thing I notice about all three of these fractions is that they are all greater than one whole. The question is how much greater, and how can we use reasoning and benchmark fractions to help compare them. And the next thing I want to look at is the size of my units. Here I have eighths, halves, and fourths. So since all the unit sizes are different, I can't just look at the numerator to decide. The next thing I want to think about is the fact that this one is written as a mixed number, but these two are written as improper fractions. So to help make comparing these easier, I am going to turn these two fractions into mixed numbers. So to convert 13/4 into a mixed number, I'm going to ask myself, how many groups of 4/4 are in 13? And the answer is 3, and that would use up 12 of my fourths, and then I would have 1/4 left over. So here, instead of 13/4, I now have 3 1/4. Okay, 9/2, I'm going to do the same thing. I'm going to ask myself, how many groups of 2 halves do I have in 9? And the answer is 4, and that would use up 8 of my halves, and then I would have 1/2 left over. So instead of 9/2, I have 4 1/2. So now I have 3 fractions, and my smallest one, none of them are smaller than 3, and none of them are larger than 5. So I'm just going to draw a number line with 3, 4, and 5, because I know that 3 is the smallest, and none of them are greater than 5. So 4 1/2, that one looks like it's going to be the easiest to put on my number line. I just want to find where my 4 whole is, and then go halfway between 4 and 5, and there I have my 4 1/2. Now I can tell that this fraction is the largest because it has the biggest whole number. This one has 4 holes, but my other ones have 3 holes. So now I want to use my benchmark fraction of 1/2 to compare these remaining two. I know that 3 1/4 is just a tiny bit away from 3. So I'm just going to estimate and put my 3 1/4 just a little bit past 3. Now 3 6/8, since it's already 6/8, I only need 2 more eighths to get all the way up to 4 whole. So that fraction is going to be very close to 4 whole. So there I have 3 6/8. So now you can see that I put them in order. 13/4 would be my smallest one, which is less than 3 6/8, which is the one in the middle, which is less than 9/2, which is my 4 1/2 way over on the end. So you can see I did not do a whole lot of calculating. I wasn't changing the denominators or making them equal, and I just realized I made a mistake here when I was writing this fraction. This should be 3 6/8. So even though they have different denominators, I can still use that logical reasoning to position them on a number line and put them in order. So we're going to practice again with 3 more fractions. So again, the first thing I'm going to do to make this easier for myself to compare is convert all of these into mixed numbers. So this one already is a mixed number, but I want to change these other two. So to change 58/8 into a mixed number, I asked myself, 8 goes into 58 how many times? The answer is 7. That would use up 56 of my eighths, and then I would have 2 more eighths left. So now I'm just going to look at that as a mixed number. Over here we have 30/4. 4 goes into 30 about how many times? The answer is 7. That would use up 28 of my fourths. And I would have 2/4 left over. So I can look at that fraction as 7 2/4. Now I have 3 fractions that are all converted to mixed numbers. They all have 7 wholes. So my number line, I'm going to start with 7 and I'm going to end with 8 because I know that all 3 of these fractions are going to be somewhere between 7 and 8. And the first one I'm going to look at here is 7 2/4. And I look at that 2/4 and I automatically know that that is equal to 1/2. So I can position that fraction right in the middle, 7 2/4. Now, even though my eighths is a different size unit than my fourths, I'm going to use this benchmark of 1/2 to compare them. And I know that 4/8 is equal to 1/2 and 5/8 is a little bit more, and 2/8 is less than 1/2. So now, without even doing any other calculations, I can put these in order on the number line because I know that 7 2/8 is less than 1/2 and 7 5/8 is more than 1/2. And remember, this is my 1/2 mark right there. So now I can write these in order. I can say 7 2/8 is less than 7 2/4, which is less than 7 5/8. Or if we wanted to use our improper fractions, I would just have to replace the 7 2/8 with 58/8 is less than 30/4, which is less than 7 5/8. So again, I'm not doing a ton of crazy calculations or changing denominators. I'm just using that reasoning and thinking that, well, 5/8 is a little more than 1/2. 2/8 is less than 1/2. This is exactly 1/2. So when I know that, I can put them in order and position them on a number line. So I would like you to try this one on your own, 29/7 and 31/8. Think about the size of the units. Are they the same or different? My recommendation is to convert these into mixed numbers and use that to help you solve the problem. Okay, so to check our work, I'm going to turn 29/7 into a mixed number. And that I end up with 4 wholes and 1/7 left over. And then 31/8, I'm going to turn that into a mixed number. And 8 goes into 31 3 times, which would use up 24 of my eighths. And then if I count up, then I have 7/8 left over. So when I'm comparing these, I can see that 4 1/7 is a little bit bigger than 4. 3 7/8 is a little bit smaller than 4. So without even changing any denominators, I know that that is going to be the larger fraction. This one will be for the Edpuzzle quiz questions. We have 5 1/3 and 5 3/4. So use your reasoning comparing two benchmark fractions in order to tell me which of these fractions is larger. So I need to know the greater than, less than, or equal to, and then a brief explanation of how you know. Are you comparing it to 1 whole? Are you comparing it to 1/2? And how do you know which one is greater? And same thing for this problem. You've got 2 improper fractions. My suggestion is to convert them into mixed numbers and then use that reasoning and that comparing to the 1/2 benchmark fraction to determine which of these is greater. So in your answer, choose greater than, less than, or equal to, and then write a brief explanation as to how you know what was your reasoning process. And last question for the night, 5 3/5. Is that greater than, less than, or equal to 5 5/10? And again, choose greater than, less than, or equal to, and then give me a brief explanation about how you know. Please bring your questions back with you to class. We will continue working on this tomorrow. Have a great night.